People tell me, Luca, you work on a front end. You're a bunch of hipsters. You have things coming up all the time, lots of libraries, solutions, languages, trying to revolutionize the whole industry all the time. Everything you can start using today is going to be out of date tomorrow, just within a month or 2 or 3. And although you may disagree with that, we have to recognize that there's something going on in our industry. I mean, JavaScript fatigue, I've been feeling it. So I've been thinking about it. So why is that so? Why are we dealing with all this complexity and things going on? My name is Luca Marchesini, and I used to be a full-stack developer. Now I work at Castle, and I make memes. And to answer that question, I've had to ask myself another question, which is, what was the first problem we were trying to solve from the very beginning? What are we trying to do in the first place? So my interpretation of the facts is that since the early 90s, where actually web pages were a thing, we are trying to make something which combines the advantage of a native application in terms of snappy UI and fully interactive experience, which actually enables the user to solve complex tasks. And at the same time, we want it to be easily accessible, like a web page. Everybody knows that to give someone access to a web page, you just hand it a URL or a link, just click on it, and it works everywhere, on every browser, on every device. So if we take a look at the stack of a native application, we know, who knows how it's this. There's a UI layer that sits on top of view logic, which works with a business logic, which interacts with a persistent layer, sometimes with an ORM. And what is this? How is this work? OK. So the difference between the two is that the web page has a static UI. At least at the beginning, the UI was really static. It was pure HTML. And between the UI layer and the view logic, we had the network, introducing the latency that we always have to deal with. So I think that what we are consciously or not trying to do since the very first years of the early 90s is just make pages fully interactive. And in order to do that, we first need to be able to change the appearance of the page without reloading the page, because reloading the page is not instant. We have this very ugly blank screen that bothers the user. So in 1995, we were just trying to figure out how to make HTML pages, and then boom, JavaScript landed on the browser. And the first thing that we thought we could use JavaScript for was make snowflakes fall on the page. That's why I say that we may not be really conscious about the opportunities of JavaScript at that moment. But then things went on, and we really wanted to be able to load new content on the page without reloading the page. But then we had to wait 10 years and have AJAX requests. And then we were technically done. We were able, at that point, technically, to build fully interactive application within the web page. But we didn't go straight to the point, right? We all know that we had a really big problem of separation of concerns, because at that time, we still sent chunks of HTML through the wire in response to AJAX calls. So both the front end and the back end were concerned by page composition. So, and also, we didn't have Node.js. So we were writing in JS on the front end, and then on the back end in Ruby, PHP, or Java, whatever. So in 2010, first generation of UI libraries came out. I'm talking about Backbone, Angular, Ember, and many more, but those are the most famous. And what happened at that moment is that we were able to pull the view logic out of the backend and just leave that concern to the front end and make the server just expose a REST API and make JSON, pure JSON data flow through the wire. So we were able at that point to split concerns and teams, which was great. We just had to make a contract between the front-end team and the back-end team, and that was a human problem, very easy to solve. And then we were done. It's OK. Calm down, Steve. Look at how the native application engineer did the UIs. And look at how we did the UIs. That's the code that we needed to write in order to nest a view in another backbone view. And when I realized that, I felt pretty much like this. We definitely needed to do something. And at this point, it's really a concern of developer experience. It's very interesting for me what drives those innovations. At a certain moment, it was just user experience. Now, it's developer experience. Be more productive. 2013, second generation of UI libraries, React, Angular, Vue.js, Polymer, Cycle.js, many more, which introduced a lot of new things, but here, what I'm interested about is the concept of component. Components, as we all know, are the basic bricks that we build our web page with. And the interesting thing of a component is that we can really describe every aspect of that chunk of interface in the same place. What I show you here is a Vue.js component that I really like because it's very clear. You have three tags, style, template, and script. And that's all you need to define a component. The beauty of this is that each aspect is defined in a different language. And the language is very specialized for that precise thing. Also, a component exposes a clear API of input and output, props and actions or events, which allows the developer to exchange and distribute the component to other developers so that you don't have to bother what's inside a component that you install from npm, for example. And this would allow us to create tools like this, the Polymer Designer, which today is just a prototype, but I'm sure that in the future, we will use more and more RAD UI composition tools. The great thing about the Polymer Designer is it really generates real Polymer code that you then can work on. So we've gone a long way so far, so what do we still need? Today, if we are offline, even if all our assets are stored in the browser cache. We want to access a website. We've been there yesterday. Now we're offline. We see the dinosaur. Native applications don't do that. You open a native application and you have some content that you've been visiting before. You can see it. We have the dinosaur. Why? Let's kill the dinosaur. Let's provide the user with some real, compelling offline experience. And then what we are doing today is first-class applications, web applications. And why wouldn't be present among the other application of the user? Why don't we have an application icon within the application menu of the user? And then native application can bother the user with push notification. Why shouldn't we do that? Actually, all these things are possible today, and they are known in this terms. Progressive web application is like a technology bundle that Google pushed forward a lot, and which really, to me, is the last step that we need to make in order to provide a real, fully interactive application-like experience to the user. But unfortunately, it's not supported by all the browsers. Guess who is supporting that? Chrome and Firefox. Let's see what happens. My dream is actually to be able to leverage all that technology and really, make real application in the web with web technologies. Data. I want to talk about data because we've been talking about UIs, and that's one thing that we deal with, and then the other thing is data. We always have to manage how the data flows through our application. And the main problem is what happens when data changes. The main promise that all the UI libraries we use is to keep the data in sync with the UI, or the opposite, the UI in sync with the data. Okay, this is a piece of junk code that I show you. So please, children, don't do that at home, okay? Here, where's the data? Because we check the DOM, and then if the menu is closed, we put the class, and if the menu is open, we remove the class. So where's the data here? Where's the state? The state, my point is the state has always been there. In the previous slide, what we did is just check the DOM for the application state. And we basically use the DOM as the representation of the application state here, which happens to be a very bad idea. So, yeah, the state has always been there. The only shift we've been doing is to choose to describe the application state in another way, to separate it from the DOM and put it in global variables, like here. Again, junk code, don't do that at home, children. Here we just, we represent the state of the menu with a global Boolean. And then we keep that Boolean in sync with the state of the DOM node that we use to represent the menu. So that variable is the state, the data. And the great thing about React, when it came out, the great revolution to me, is not only that they abstracted the DOM through the virtual DOM, but they really enforced this idea that we should manage a state somewhere which is completely independent from the UI state, and then we just use the components, the React components, to map that state to the DOM, but never access directly the DOM. Or yeah, sometimes you don't have the choice, but it's commonly known as a bad practice. So I suddenly became aware of this concept of state. So you have this state, and you have to do something about it. But the question that React doesn't answer is, where should the state live? You have all these JavaScript objects, and where do you put them? So if you use vanilla React, you can scatter your state across components and let every component manage its own state, like we did in Backbone, like we did, all the time. And as long as the application grows big and complex, we understood that it's a very good idea to gather all the state within a store, which is what Redux enforces, what Flux enforces. This is not an invention of Redux, but I think that when Redux came out and when Flux came out, that this idea was really, blatantly shown to the community. So we suddenly were conscious about this. So when the store is there, what happens is that we introduce a new layer to the front end, which stores the state. But the state of the application contains two sets of data. One set comes from the user, which is basically it's calculated from the interactions of the user with the UI, like some clicks here and there, or some forms that are fields. And then the other set is the data coming from the server. And if we use the store to keep the data that comes from the server, we are actually talking about a local cache. And the local cache is always something that we somehow want to keep in sync with the thing that is being cached by the local cache. So in this case, we are facing a new data binding problem. The binding between the state of the store in the front end and the state of the backend, the data in the backend. And how do we implement this data binding mechanism? By calling the REST API. I really don't like REST APIs. I think they really don't fit our needs. And I think I'm the third person in this conference talking about the problem of overfetching and underfetching. So I think that it's useless to talk about it right now. So I think we can take the time that I've used to this to do something more fun, like having a chat with the captioner. With the captioner. Hello, are you enjoying the conference? I wanted to thank you for fixing all my English errors. And I also wanted to really compliment you for the job you've made during Jafar's conference, because actually Jafar talks faster than my brain can think. And all the things that Jafar said were actually written down there, so it means that these persons can type faster than I can think. So you guys are doing an awesome job. So thank you very much. Please. Overfetching and underfetching. Say this is, we always say we are and who are our friends. So the API, the REST API doesn't fit our needs. We do round-trip requests to get a lot of useless data, and we bloat the network, and then we have this first world problem of tight coupling we don't really like. So how do they do in the backend? They query, basically. They send a query to the persistent. So why don't we do the same thing? This is the purpose of GraphQL and Falcor. We've seen GraphQL before, and Falcor is another tool that basically resolves the same problem on the server. And there's another one, which is called OnNext, which I won't talk about because I don't understand anything in ClojureScript. But the next talk is about this. So what happens on the server? You just have one API endpoint, and you send a query. And then you have exactly the same data that you want. Nothing less, nothing more. And now we are over with overfetching and underfetching, but still, we don't have a clear way to leverage the fact that we can cache that data. The data that comes from the server, we can keep that on the client and then use it to optimize the further requests that we want to make to the server. And that's where the Falcor client and Relay come into play. These are the new kids on the block. And basically, the Falcor client interacts with the Falcor server, and Relay interacts with GraphQL. And what they do is, in the same way that React introduced this abstraction layer between the developer and the DOM, saying, don't worry about the DOM. Just give me the state, and I will patch the DOM in the best way as possible. Falcor and Relay do the same thing with the network. They are saying to the developer, don't worry about the network. Stop querying the network. Stop sending requests. Just ask me the data. I will provide you the data as soon as possible, in the best way as possible. So they are managing all the data caching for us. They are managing all the request optimization for us, and we'll see that in a moment. And they just let us specify what data we need and just wait for the data to arrive. In this case, we are introducing a new OGM layer to the front end. I say OGM because Falcor and Relay work with graph, because actually it's the best way to model our data. And the interesting thing here is that we are starting to consider the backend as some sort of persistence layer that we don't want to know about. We just know there's some sort of latency, and that we don't bother about it. Demo time. That's when things become interesting. Okay, what are you seeing here? Tac. Okay. This is what I have in my backend. Let me just resize the window. This is a list of products that my REST API just responds. When I ask to search for the products, I have this. These are Italian food that I sell to my colleagues at Casol. And we have all these useful and less useful fields, okay? There's especially this one and this one. And now I want to be able to query those fields. So what I make here, okay, I'm here. I'm demonstrating Falcor, okay? It doesn't mean that I think that Falcor is the best solution ever. It's just that Falcor isn't coupled with React. Since I'm not a React developer, I use Vue.js. It was just the best solution for me to show you the idea behind the thing. So here is, we are querying. We have this model variable that I've exposed as global. And I just say get value. And then here, I specify my query. In the query, the nice thing about Falcor queries is they are really similar to the JSON syntax. So I have this set, which is products by ID. And this is the ID of the Parmesan cheese that I want to see. And this is the title, OK? And then get value returns a promise. The real type is actually unobservable, but it really behaves like a promise. So I said, then, when the data is available, I want to show it. So here's the data. OK? OK, let's take a look at, this is the query. Am I right? Yeah. Yes, this is the response of Falcor, okay? It just sent me the title. What happened on server side? Let's see. This is my Falcor code on the server side. Falcor on the server is just an express middleware that you just plug a router to and then specify what your routes do. So, okay, this is my router create class, and then I define a route. This is the matching pattern. So that's how I tell Falcor, what do you have to match in order to enter this route? And then I specify the method, which in this case is get, because I just want to get data. Methods can be get, set, and call. So in this case is a get, which always returns a promise. And then here, this is my code. It just, I make a call to Casol to get some data, and then when the data is available, I just resolve the initial promise with the data that I format in the file core syntax. Okay, is that clear? Is that okay for you? Does it make sense? Okay. Can you read? Do you want me to? It's okay? Okay. So basically, when the data come back, I have my title. So now, let's try to ask another field here. Say I want to get the description of my product. Okay? I have an error. Ah, yes, it's always the same, because I always get caught by this. In Falcor, when you want a value, you use get value, so you just have the value. And when you want multiple values, you use get, which actually returns a JSON graph object. So here you can see I have my title and my description. But look at the response of the second request. Falcor knows that I have the title in cache. So even if my query was asking two fields, it tells the server, okay, just send me just the description field because I already have the title. And what I really like about it is that Falcor tries to make this metaphor, to create this illusion to the developer, which is just code as if the data was present on the local machine, just like it was, if it was synchronous, okay? Like, don't worry about where's the data, where comes the data from. I just manage it. And so, what if we could code like really everything was here and we could synchronously get the data? Well, we actually have seen a very interesting talk by Jafar today, and we've seen all this async await thing. So take a look at this function I'm writing here. Load model. So ask the Falcor model 3 fields, but we use async await. So we don't have to put the then here. It's just like synchronous code. And then right after the Falcor model.get, we JLog, we log the value, like if it was synchronous. And the great thing is that it works. This is the response of, you know, you have the 3 fields here, so it worked. Like it was synchronous. I'm pretty shocked about it. I have to watch twice all Jafar's talk to understand, but I was happy about it. So another great thing about this kind of approach is that we can co-locate data requests. Co-location means that within our components, we can specify the data we need. Until today, I used to do Vuex, which is a Flux implementation for Vue.js. So the place where I specified the data that my component needed was in an asynchronous action. So it was completely separated from the component. Here, I'm in this product list component, which is actually, let me just go to the home page of my website, okay? So this is a product list with all the products, and my list, this is the code of my component, the list component, and here I specify exactly the data that I want for my component, which doesn't mean that the component is in charge of fetching the data, because this would imply tight coupling. In this case, the component just expresses the need for data, and then Falcor is in charge of it, which Falcor is actually completely separated. But hey, it misses something, no? This is not a proper e-commerce platform. You know, we have the name of the, okay, it's in French. My colleagues are French, it's not their fault. I'm sorry. We are not showing the price. Oh my God. Let's get the price. To get the price, I think you already know it. We just have to add a field to our query and don't touch a single thing on the back end. And it hot reloads. What can we ask for more? Great. So this is the power to me of Falcor, and it's something we can do, obviously, with GraphQL as well. This is not the same approach, but hey, it kind of works. Where's the menu here? Duck, and bam, it works. So we don't know what. We have made a lot of progress, actually. But I think that today, we are kind of concerned with speed, okay? Many people are complaining about speed, especially on the mobile web, and this is not good. I think that one thing that we can do is just drop REST APIs and just go query, and use solutions like Falcor and Relay and GraphQL, and save a lot of round trips and useless data overfetching. Of course, these solutions are pretty new, and there's still a little bit of friction to adopt them. It's not very easy to set up a GraphQL or Falcor server. We have to grasp things. But we are especially concerned by these kind of problems at Castle, and we try to work to provide a one common running backend that just provides you a Falcor model or a GraphQL query endpoint. And I mean, I hope that in the future we'll be able to have all these things out of the box. HTTP 2. Many people in this room have seen the talk that we've seen on Tuesday about HTTP 2. HTTP 2 is here. It's going to dramatically speed up our things, and network round trips are not going to be such an issue, so let's adopt it. It's my dream to see a fully worldwide HTTP 2 web. And then I wanted to talk about data binding. Data binding comes down to observing. We've seen that keeping things in sync is a common pattern. We have this pattern since the 70s. We know that observation is the best way to keep things in sync. In our UIs, we use the components as observers that then map the state to the DOM. But all the frameworks that we use implement this in different way. Events, dirty checking, virtual DOM, reactivity. I think that data binding should be embedded into the language. And this is what Jafar's talk was about. I think that observables are really the key solution, the most elegant solution to this problem. And actually, all the RxJS implementation are going through this direction. I hope that the RxJS implementation will be embedded into JavaScript soon. This is one of my dreams. And I also want to talk about virtual DOM. Virtual DOM is great because it introduces this abstraction, which actually works very well, but it's also good for performance. Because imagine we have a DOM change. We trigger it, and then the browser goes on and restyles, relayouts, and repaints everything. This is very costly. Another DOM change, another round of restyle, readout, and repaint, and so on. What the virtual DOM does is buffering the DOM changes and then trigger them, flush them all at once, and save a lot of calculation of restyling, relayouting, and repainting. I was asking myself, why don't we make virtual DOM native? Why don't we make browsers expose some kind of virtual DOM API, something that would allow us to say, hey, look, I have this change, just buffer it, then this one, and this one, and this one, and then just flush it. And then you do all the calculations. Obviously, virtual DOM also computes diffs, so it doesn't mean that virtual DOM is would be completely useless, but I think that virtual DOM libraries would be lighter. So it would speed up page loads because we would have to load less JavaScript in this way. So let's go back to the beginning of the talk and just, why are we doing all this? What was the problem since the beginning? We are spending 20 years and more trying to provide the user with a fully application-like interactive experience. And we're trying to do it through some kind of software that executes in a distributed environment, which is instantly accessible with just a URL. And this application has to be executable in all the existing browsers, and there's a whole bunch of them, on all the existing OS, running on all the existing devices, in all the possible network conditions. And these are all factors that we don't control. And this is just in order to achieve the largest amount of users and in the end make them happy. I think that we have a lot of things going on in our community because the problem is complex and it's not solved. And, you know, we are finding solutions that are just awesome. Think about the network abstraction introduced by Relay and Falcor. This can benefit all the industries that work with distributed application. An iOS developer, an Android developer would benefit from having you know, the network abstracted and don't have to bother about it anymore. So from our community, we are really introducing this great innovation that we can spread around. And if you take a look at how the front-end environment evolved, we can see that the stack is not very different from the native application stack, especially if we consider that the backend is like a persistence layer that we abstract. Today, we have a front-end that embraces the full stack. And I think this is possible because the language that we use has evolved a lot, and it's now a first-class application programming languages. And I'm obviously talking about JavaScript, which is the language of our community, the language that we use every day to express the problem that hassle us every day when we wake up. We are people that work a lot, that are really concerned by this problem. We spend a lot of time working on free open source projects. We spend a lot of time on the social network, trying to communicate with other people and find solutions, maybe arguing sometimes a lot, because these problems matter for us, because the users matter for us. I think we are an awesome community. My friend Steve would say, I have 4 words for you. I love this community. That's the way he would do it. I think we are not a community made of hipsters. We are a community of dreamers. And let me say that I think that our dreams are close to come true. Thank you very much. I hope you enjoyed the conference.